Live. Question mark. Period. I guess we started with period. Okay. Actually, I don't think there was any punctuation there. Start. So, hello, no one. And now, hello. Anybody who's in the Getter channel pretty soon in a second. Raw, uncut footage. That's what this recording is right now. Okay. So now, anybody who is watching the Getter, which I'm not sure if anybody is, there is one person. Welcome. Seraphim Streets. Have you played Command and Conquer? Or not Command and Conquer. Sprint Commander. I love Sprint Commander. There's analogies to be had with Sprint Commander. Actually, I think I did an analogy, and feel free to do an analogy with Sprint Commander. I did an Age of Empires analogy. Okay, so let me text Jane. Let me text Noah. Okay, there's got to be a better way. There's got to be a better way. Now I go to the Getter on my phone. Maybe I'm just really bad at using computers. Maybe that's my problem. Maybe all of this is easy. I don't know. I'm not able to figure it out, but hopefully the AI will. All right, that's the name of the game. So where were we? We talked about overlays. We kind of wrapped up nicely. That wrapped up really nicely. I haven't rewatched it. I ate dinner, but I remember from a few minutes ago that it wrapped up very nicely. Okay, so let's get into DIDs. DID, well-known configuration. So let's jump to this actually. So I found this really interesting. So there is something called a .well-known, a IETF 8615 well-known resource. So this, I mean, I found this tantalizing. So yeah, I just found this really interesting. So essentially, we should probably read, all I did was skim it once again, so we should probably read it just to confirm what this memo defines a path prefix for well-known locations /well-known/ in selected uniform resource identifier schemes. Selected uniform resource identifier schemes. So it obsoletes RFC 4 or 5785 and updates the URI schemes defined in RFC 7230 to reserve that space. It also updates RFC 7595 to track URI schemes that support well-known URIs in their registry. Okay, so first of all, what the hell is this thing? What is this document? Many of you may not have seen what this is. So these are called RFCs, request for comment. Request for comments. Yeah. And this is the number. So they each get assigned a particular number, um, kind of like CVEs, right? And this one looks like it was written by somebody named Nottingham in May of 2019. So there's links in the tutorial series draft notes where we talk about how we want to take this through the RFC process. I need to get back to Jeremy on that. And basically that means we want to write one of these things. And what we're going to do is we're going to write it just about, what is this architecture? Provided this thing, works, then we should write an RFC for it because we're writing an RFC for the format and for essentially, because effectively all we're really doing here is defining like this C style function prototype for whatever you want, right? Um, and then, plugin system for kicking it off. Um, and so um, that could be implemented because it centers around the fact like the format of the manifest and the proxy for other formats. Um, the domain specific formats. That is something that sort of belongs as an RFC. So where's a good RFC to go over? So where's I like the DHCP RFC. DHCP RFC. This one is really nice, and it has. What's your favorite RFC? Tell us in the comments. Um, um, what is the fun one? RFC 1149. So if you ever wanted if you're looking at upgrading your internet, I highly suggest um, looking into Avian Carrier as a potential tier one network for you. Um, this is hilarious. Basically, they say IP over carrier pigeon. So that's my favorite funny one. This is my favorite one for this diagram. I love it. So this is nice because so these the authors of the DHCP protocol, and that's the how we get IP addresses on a network, right? That the outer router will issue out these DHCP blobs. It's going to send these over the whatever it is the physical. It's going to send them over one of the layers of the OSI stack. Um, it's going to send it over UDP. I believe it's a UDP packet. So it's under transport layer. This is a transport of sorts. Yeah, I think so. But basically, there's a state machine. Here's a nice state machine diagram, sort of. It's more of like who's talking, but it's also a state. Timeline diagram, that's what it is. So basically, this is my favorite one because I mean, this thing is beautiful. This is beautiful. I mean, this is just, yeah, I love this. I love this thing. This is great. So these people did a fantastic job. Because when you go and you try to parse things, this is just like the quality. The quality here is just very rare in documentation of formats, right? So what basically the DHCP RFC is inspiring, and so we should also RFC this and try to do half a good as job. So because this is the sort of thing that you write in RFCs for, based on my understanding at least, is hey, I've got this protocol. Want to, we want to sort of talk this open We're just putting this out there, right? Like, this is what we're doing. This is why we're writing this up and we're doing all this stuff. It's like, hey, we're just putting this out here. We're requesting your comments, right? We're doing this thing. This is the file format. And if you want to get involved, uh, you can, join. Uh, you c- you can back in 1997 you would send them a letter. No, yeah, I guess you would send them a letter, or maybe they were on the internet. Um, um, and yeah, okay. So I wonder how much spam mail the Free Software Foundation gets. So okay, look at this. This is just beautiful. Um, Okay, so so we should strive to do something half as good as this. If we can do something a quarter of as good as this for the first draft here, we can always do an obsolete. But this is just perfect. So this is an RFC. And why were we here? Okay, so we're talking about these, and I mean, when I say we're going to do an RFC, I mean we should RFC this like open architecture, this whatever this thing is, right? This uh, execution um, mode um, and the format thereof to to see if there are edge cases, right? Because when you put something out there, then other people can comment and say you missed this, and we all work together and we can fix it and we can grab that edge case, right? Or we can just say, hey, maybe there's something else that's needed. Now what we're saying here is basically we're defining something that's a generic proxy for whatever else. So if there's something else that's needed, then we have a problem basically, and we need to go update the RFC then, and account for that. So okay, da, da, da. Is this working? Yes, it is. Okay, great. All right. So now we're reading. So and let's pop back up our stack. So ret, and now we're back at the well-known DID configuration spec. Okay, so let's go back and so we were here, we're investigating what is this thing? Why are we here? Well, it says it makes it possible to connect existing systems and decentralized identities, or making it possible to connect existing, so it's laying some context for us. So making it possible to connect existing systems and decentralized identifiers is an important undertaking that can aid in bootstrapping adoption and usefulness of DIDs. One such form of connection is the ability of a DID controller to prove they are the same entity that controls an origin. Okay, so what does this remind us of? I'm just going to run through this. They might tell us. The DID configuration resource provides proof of a bidirectional relationship between the controller of an origin and a DID via cryptographically verifiable signatures that are linked to a DID's key material. This document describes the data format of the resource and the resource location at which origin controllers can publish their DID configuration. Due to the location of the DID configuration resource, discovery of associated decentralized identifiers against an origin is trivial. However, the inverse, i.e., given a DID discovered, the associated origin is deemed out of scope. So given a DID discovered, the associated origins is deemed out of scope, and that is what we're addressing here. So basically, here's the DID. Go get some information. Why did this get added here in the first place? That's what we're doing via this manifest stuff. Is at least as far as I'm reading this so far, that's my understanding. So we need to connect with these guys, and we need to understand um, what they're working on, and whether that was out of scope intentionally because of what they what are they doing? What is this guy doing? We'll see the company. New world of data and digital trust. We need to understand, we're going to connect with them, but first off, we should understand, how are we going to be received? Like, are they thinking about this already? Is this within scope for them, or this is not, it's out of scope. That's why it wasn't covered, or, is some other working group working on it, right? So, because there was no mention, usually there's a mention of another working group if another working group is in flight on something. And, it could be that the docs are out of date, there's active discussion happening, or really there is no working group. And then this is a place where then we would go create a working group around, around that, right? So, um, yeah, okay. So and what is that? That is, um, however, the inverse is deemed out of scope. So basically, given a DID, discover the associated origins, right? And that's what we're saying. We're going to add that information to the chain as a manifest. So let's go ahead and email them. So how should we do that? Well, this is how you find out when you have open source people and you need to email them. Oh, this guy. This guy's great. Um, I'll just ask him on Twitter. Perfect. Okay, so now we go to Twitter. soft, software, software engineering 101. Now we go to Twitter. Oh, I don't know how to sign in on this. Okay, so now we go to Twitter on my phone. Live to Twitter on my phone. Ain't that the state of it, how it usually is. Okay, live to Twitter on my phone. So now we're gonna ask Daniel what's with this well-known identifier spec, um, and why is that out of scope? Here he is, my last search person. He's coming up with a bunch of good stuff. Um, let's see. Yeah, I probably. Oh, I grabbed something that I saw. He said the other day to put in a link in the comments in the discussion thread. Okay. Um, so what do we want to know? We want to know. Hey, Daniel. We'll just tweet at him. Um, and we'll tweet at him in this thread. So, okay. And then I'll ask him. Daniel, in the DID well-known spec, um, and just to recap on what I'm doing here. So what we did is we're reading through the specs, right? We realized that there's a potential. So this stuff is evolving, right? And so there's this potential that uh, we see it's out of scope, right? I don't know where to find the full list of what is in scope and out of scope. Maybe it's that I'm jaded by bureaucracy, but I don't think it exists. Um, so if it does exist, Daniel's going to tell me right away. He's just going to be like, he's nice. So somebody less nice would say RTFM, but then he'll tell me, here's the docs. Then I can just go look at the docs, right? If he says no, that doesn't exist, um, then we begin discussions with whatever the parent working group is, which looks like the W3c in this. Is this the W3? No, this is the Digital Identity Foundation. So then that's the parent. That's the parent association of the oh no, the DIF, the Digital Identity Foundation. Yeah, the Digital Identity Foundation working group. Is it Digital Identity Foundation? Yeah, I guess it is. So they're the parent working group. So we would work with them to understand whether a new working group needs to be formed. Um, so this is just like sort of how you navigate um, when you see a gap in like the overall, like you're looking at the strategy, you're looking at, these are like the plans. When we issue specs, it's like, hey, this is the format, just like the RFC. So they said they started building it DHCP servers. They're sitting there in their labs and they're assigning things IP addresses, and they're like, this sucks. Let's make the computer assign the IP addresses, right? And so then they go and they write this piece of software, and they're like, okay, here's this packet format that we designed. They're like, hey, it would be great, since this is a networking project, if other people, I should tweet this. No, I'm going to forget. If other people, um, if other people who ran computers that went on networks, we could talk to them, so we shared the same protocol, right? So how do you do that? Well, you publish an RFC because it says, hey, everybody, I think, what do you think about using this? I'm using this, right? So if you interact with my computers are going to be using this, right? Ah, and so what do you have when you have like this Web3 plus Edge thing, right? Well, it's, hey, everybody, here's my computers, right? How do you want to interact with my computers, right? So you need some kind of format to interact agnostically, like your application. It's essentially like a wrapper around the application layer. It's just like we need another layer because we always end up doing this, and it's just your wrapper around your what would usually sit. It's the first thing that sits in your application layer, um, because it's going to be above your TCP or whatever, right? And it's like, okay, well, it's like it has some knowledge of the data, right? Which is where you need the manifest, right? And because the manifest is just like a generic term to describe this little blob of data that's just bytes that you can find. If it's just bytes, right? Or a stream or whatever, right? And so this is what we're saying is we're defining an open protocol for the application layer or something like that, right? Um, and that open protocol for the application layer is DIDs and web nodes and all of this stuff. That's my understanding of what they're saying. Um, and so the fact that this last sentence says it's out of scope and there's no references to anything else that says scope of anything. Now, that also doesn't mean it's not there, because this also doesn't reference the rest of the DID. Okay, no, it does reference the DID. Controller, subject, issuer, DID document. DID, linked data proof. Okay, linked data proof it could be. Linked data proof. Okay, credentials are part of the daily lives. Okay, but this is about credentials. See, this is missing execution still. The execution is a critical part. Okay. Unless it's not. Subject. So I think, are we implementing verifiable data, verifiable data registry rules this way? Verifiable credentials. This all has to do with credentials. I think we might be an edge. I think we might be the same as this. This might be it. Verifiable credentials use case done. I think they're just talking about it through the lens of credentials. Put away my phone for now. See, this is why you read more. See, we might not have needed to tweet. Um, that's basically when you basically never need to tweet. Following terms are used to describe content in this specification. Data minimization, active owner data minimization, data strictly to minimum necessary. Decentralized identifier. Derive decentralized document. This is a document as verifiable data registry. Contains information related to a specific decentralized identifier, such as the associated repository and public key information. Okay, this is critical stuff. So this is going in. This is going in. So so now this is going in a node. So where is our volume 0? All of these have links. So where are we? We're in introduction and context. Okay, so here we are. Okay, we wrote that down. Good job. Um, that helped to write it down. I actually remembered it this time. Okay. We'll say DIDs. I'm going to subheading this by what? So let's see. So we're going to go ahead and what is this? So this is effectively we're writing this. So this is the introduction. It's like a little, this is all sort of introduction here. Or are these separate? What are these? You get too used to writing like it's documentation. Are these chapters? I think the expectations, these are notes. Um, and the manifest is also referred to as the universal blueprint. Um, or I think there's one more thing. Standard interface. We've talked about this like a million different ways. Um, I think it might be this stuff. And this is the tricky part is understanding, and this is the thing that Alice is going to have to do, right? How are we going to make it so that Alice knows how to do this process, right? Because this is the process of going through and saying, where's the edge? Where's the edge of the train of thought, right? The train of thought is Web3, right? So where are the leaf nodes? Where are the leaf nodes, right? The leaf nodes in that train of thought are the current specs in flight. And then you have leaf nodes off that, and you're treat it all as if it's like a fork, right? And you're forking off of everything is code, basically. Treat it as if, think of it as if it's all code, right? And you're seeing these specs because it is code, and you're seeing these specs, right? And you're like, okay, well, it looks like this leads to this leads to this, and you're looking at all this RFCs, and basically, like, if you're looking at research, so look at research in the field, right? Like in research in a field, right, where people are publishing all these papers, and there's citations, right? Um, so if you want to find out what's the state of the field, like in some train of thought, where a field is a train of thought, then you uh, you figure out what are all their publications, like what are the places that do publications, right? What is the tiers of sphere of influence of the publication? What is the category of customers, right? Like and what is the and by that I mean like what like is this, sort of do your like small, medium, large, right? So uh so uh let's see. So within a project, we do ADRs, right? So an ADR would be like the lowest scope level of RFC, right? Like it's within the repo, right? The people who need to know about it, they're somehow they're interacting with this repo, right? Um, then you get to like the uh, the W3c specs, right? So these are things like primarily related to web browsers and stuff, right? So this is a much bigger area, um, and um, yeah, much bigger area, and in terms of user base, and then you get to things, and then for example, you're looking at RFCs, right? And in RFC, um, like DHCP, like this is on every network, right? So they go through this uh, thing. They go through this thing called the Internet Engineering Task Force, I think, and that goes through another organization. And this is all in the Alice discussion notes. And so then they publish it, right? And so this is and this is why we're interested in publishing this as an RFC if they haven't already, but it looks like they have it as a spec. And so in that case, maybe this is more of a spec scope thing. I mean, it definitely is more of a spec scope thing at this point. I mean, this isn't the internet. I guess what we're saying though is like everywhere there is internet, then there would be this. as well, because this defines execution, right? So everywhere there is communication, there is execution around that communication is what we're saying, right? And so it's like because that communication is context aware. I think there was an example in there about um, there's an example in there about um, um, like two people who are um, there's two people. So okay, so I've so the reason I think I thought about this is because I've had this situation happen to me twice. It just happened to me the other day again, where um, there's just like a random car stuck, and then like me and another person move the car and just like push it. It's just like random people come together and then do the thing, and it. Wait, where was this? Where were we? Oh, god damn it. Um, fuck. I lost my train of thought. We were talking about trains of thought. We were talking about two people coming. God damn it. Fine. All right. It's a signal to focus again. Okay. There it went. It just went right in the middle of it. Okay. So we were talking about how to do this, and we're trying to figure out, okay, so this points to this points to this, and then you basically map to your user base. Um, and so we're just traversing these series of specs, right? And the code that we have basically, the code that we have in the world is really like about. I think there's this guy who gave this talk about days, kind of these bunch of C++ people about data or data. Uh, um, it's like just looking at everything, just the data model stuff. It sounds like this stuff is called data model. I think we're calling it data flow because I hadn't heard anything about it. Well, because our project is called data flow. Yeah. And it sounds like data flow uses data model if you're using this terminology. So and the data model is the focus. I think we talked about that in the last video where it's like the focus is on, okay, well, what are the things? And then, what are the, the, the fields and the types and how they go within each, struct basically, right? Like your data classes. Um, and I got lost again. Okay, so basically we think that we went to go learn about this well-known stuff because this was going to be a way that we could bind the Web 2 world to the Web 3 world to begin our chain of trust because these things are a bunch of asymmetric keys from what I understand. And then because so our first step would be obviously to do this to go from the Web 2 world to the Web 3 world so we can actually bridge that in like put data in here because that's going to be important obviously. So and then what we found is that there's this decentralized identifier document. Where did that go? We went and we looked at the main what was this? Okay, and this says data model too. See, it's apparently a term. Verifiable credentials data model. Okay, so this is one of the other working groups that's active in this space. Is this verified credentials working group, which is a W3c working group. um, and this looks pretty recent. Yeah, that was just what, 2 months ago. Um, errata exists. Errata is like there were errors in the spec and we have updates. So days long. Yeah, I don't know any of those people. There's that. No, it's not. I don't know any of these people. Digital Bazaar. Yeah, a lot of blockchain people. A lot of blockchain people. Let's see. So and and I think part of what we're doing here that's kind of so the blockchain stuff like it all relies on these contracts executed within the network and stuff in these little um I don't quite understand how they trust all this stuff to run. I guess it runs the code in a sandbox. It runs it in an interpreter. That's how they trust it to run. Yeah, I forgot about that. Okay, I'm like, why are they just running people's code? Okay, well, okay, that's exactly what I'm suggesting. I think that we need to be just, yeah, well, and I mean, it's not just me. We're all suggesting this, right? Like, as a community. I mean, like, not as DFML community. I mean, like, the wider community is basically saying, hey, uh, like SGX. Well, this is Intel, right? SGX exists, right? You can run, um, you know, people if you don't trust if you don't trust, the hardware, I mean, if you don't trust the OS, then you can trust the hardware, so you can deliver your little, application, um, sort of like your box that you would put in a data center, but you're just putting it in a machine, right? So you can do your, um, you know, like this is this is what we're saying here is basically you can do this attestation, and why would you want to do attestation? Well, the whole reason why you would want to do, well, at least as far as I understand, is one of the main reasons you want to do attestation is so that you can say I can trust something, right? And so if we trust the hardware, then we can say we can trust the software, right? Which means that, okay, I may not know what you did to that, uh, you know, camera over there, right? But I can trust the software, and I can, somehow verify via like, some mechanism, maybe a model number or something that, and then I plug it in Alice, and Alice tells me, okay, that thing is only executing strategic plans which have attested provenance information, which tells me that their strategic plan took into account that they shouldn't be doing facial recognition, right? And so this ensures that no code ever runs on that device that ever triggers code anywhere down the line that does facial recognition. So we have ability to trace what happens to the data, right? Um, okay, so and what we're saying is, to facilitate this. Um, to facilitate the interaction between the devices in this sort of mesh network, you need this shared application layer protocol. And what DFFML is saying in the creation of what DFFML is saying by implementing these classes and the things we're doing in this tutorial series is that that can be done. Here's a reference architecture for how you do that on top of Web3 DIDs, DWNs, and then using orchestration from Kubernetes via the KCP project. Um, so we're providing a reference implementation, right, from which then, um, so from which then we would go and issue and issue a request for comment and say, hello, everybody. We think that we think that if you see some data, you should also get some direction on what you might want to do with that data in terms of executing it. And we should all sort of, think about providing this functionality in terms of the traceability. And here's the data model, as in here's the packet formats and the structure of the data and the sort of fields that we would need to see if everybody was sort of talking this shared protocol, and this is what this shared protocol, the properties that it gives you. And it makes it really easy to write, for example, a distributed AutoML with feature engineering, um, uh, AI that will build your software. um, so that's the plan. Um, so back to this verifiable credential thing. So the thing is, okay, so the question is this going to be all about tell me what crypto algorithms to do? Because I think that's just something we were saying we were going to table for now in terms of using these for the personal data stores. Because what we're interested in is this. Something that tells you we want, what is this? So what is this? So what is this actually? So let's look at this a different way, right? So let's look at this a different way. So instead of saying we need to put something in the DID before we've even read the DID spec, we can say that this thing looks like the DID says it's already got support for integrating with this thing, right? So now we can go look at this thing and we should say, is there any way we can put our data in this thing, right? So this is the outer wrapper, right? This is the next level parser of the, if the shim gets this thing, then what's the next thing it's going to do, right? So let's check it out. Status of this document. Oh, abstract. Credentials are part of our daily lives. Driver's licenses are used to assert that we are capable of operating a motor vehicle. University degrees can be used to assert our level of education, or government issues passports can enable us to travel between countries. This specification provides a mechanism to express these sorts of credentials on the web in a way that is cryptographically secure, privacy preserving, and machine verifiable. Round of applause, round of applause. Um, This section describes the status of the document. This section describes the document at the time of its publication. A current list of W3c publications and the latest revision of this technical report can be found in the W3c Technical Reports Index at w3c.org/tr. Okay, we don't need to tweet that. Okay. Comments regarding the specification are welcome at any time. That's the idea, right? Readers should be aware that the comment period regarding a specific version of the document have ended, and the working group will not be making any substantive modifications to this version of the specification at this stage. Please file issues directly on GitHub or send them to public VC comments at w3c.org. So red flag. Um, if we were looking at a project for analyzing the security and maintainability of it, we would say anything which leads us to believe that development on this thing may have stopped is a red flag, right? And for us, in terms of trying to understand where's the bleeding edge, like where's the latest OSI layer right now, right? That we're trying to build on top of to correctly integrate into this Web3 ecosystem, right? Then we need to go and say, skim the rest of this and okay, has received implementation feedback showing that there are at least 2 implementations for each normative feature in the specification. That's great. That means we can go run some code. The group has obtained reports from 14 implementations. For details, see the test suite and implementation report. So this is fantastic. Let's see the test suite and implementation report. These people do great work. Okay, so this is the test suite. Okay, so this is going to tell us how to run some tests, and these are going to tell us about the format, and it's going to do a bunch of stuff that says, hey, let's see. So what are we looking at? Open attestation report. See, I'm telling you. Let's see. One or more URIs. Basic documents at context must be one or more URIs. Okay, so what is this? More URIs. So this is great. So these are some kind of test case format they have that's written in JSON. And true to form, when you go to a website, it will execute the test cases. I don't quite understand why they do it this way, but I think they have some sort of test framework that's set up to work this way with their CI. Yeah, they do great work. Yeah. Okay, so let's find out where this is deployed because that can tell us the up to date. So let's see. Oh, 2021. That's not good. No, okay, this is a bigger red flag. So we need to find something that's work in progress to understand where we're at or where we should be at. Um, let's see. It may be that they just called it good, but I want to know revision history. Changes since. Okay. Acknowledgements. Oh, wow. Okay, wait a minute. Okay, another red flag here. So this was funded by the Department of Homeland Security. So that could be a good thing. but that could be a bad thing. Um, because I don't know any of the people on this draft. Um, and I know that guy Daniel, and it's a different Daniel, I think. See, this is what I'm worried about. That's why we might have already got hacked by the feds. Um, um, yeah, see, this is another thing I was worried about. Because I saw this, and I didn't say this when I read this sentence, but I was like, this specification provides a mechanism to express these sorts of credentials on the web in a way that is cryptographically secure, privacy respecting, and machine verifiable. And I thought, what reminds me of that sentence? And it is this other sentence that is in the discussions thread that says freedom and privacy preserving. And so I'm seeing the word freedom missing there. So that's a problem. So, yeah, I don't see Daniel's name on this. And the reason why that's important is because Daniel is a libertarian. Um, and so that means he's suspicious of the government. And security people need to be suspicious. So if it turns out that the US government is just all lollipops and rainbows with this one, then that would be great. But I think we're definitely going to check with Daniel first. Um, this is a different Daniel. There's a lot of Daniels. Okay, no, this is this? He was at Microsoft. Okay. Man, this is why this is hard. Okay. Okay. So what do we do? I don't want to continue without knowing where the edge is. I don't want to work in a soon to be defunct tree of or train of thought, as we'll come to think of it. Credential subjects. So maybe this is like really, maybe we should just read it for God's sake. Uh, Origins, the standard definition of a domain-based origin in the web security context. See the what WG HTML living standards origin definition section. Okay, let's go click that. Origins are the fundamental currency of the web security model. Two actors in the web platform that share an origin are assumed to trust each other and have the same authority. Actors with differing origins are considered potentially hostile versus each other and are isolated from each other to varying degrees. Okay, for example, if Example Bank's website hosted at bank.example.com tries to examine the DOM of Example Charity's website hosted at charity.example.org, a security error DOM exception will be raised. Um, so, which says the operation is insecure. I love that. The security error DOM exception. That's great. Um, okay, so the operation is insecure. Okay, so basically what it's saying is that's a really funny way to say the standard section for the domain. That's a really funny way to say if you're on the different domain name, if you're trying to access a different domain name, we're going to tell you it's insecure, is what they're telling us. Um, and that's a good thing because if somebody's hosted, a personal GitHub, Page's website under their username .github.io, you don't want them to be pulling, I mean, GitHub Pages is think of some other hosting platform, AWS or something, right? You don't want them pulling, you don't want them calling over to your domains with their JavaScript, because that would make it so that you're not sure. Like, okay, we don't need to get into this. We don't need to get into this. You can ask me if you want to know about this. You can ask me. We'll make a video about it. I think Terry has some stuff on this. I think there's like a I think she did a tutorial on this, so you can check Terry's. She maintains CV bin tool. You can check Terry's GitHub, and I think there's some stuff on web exploits, and I think there might be some stuff on same origin on there. And if not, you can look at the course post. So, okay, so let's just try to use this thing and see what happens. Let's just try to use this thing. It's out here. It exists. Okay, the other thing, we're not using the thing. We're not using the other one. We're going to make a note that we found it, but I'm thoroughly suspicious. So if you're less suspicious than me, you can go check it out, but you better have a reason why it is less suspicious. If we're going to uh, officially make it the plan, because we always try to make sure that we're going with the least suspicious options in any case, meaning always known to be at the top, the freedom and privacy preserving and secure. So if we suspect that it is, we would approve that it is that, or else it's basically like our threat model. It's an unmitigated threat, right? Where we suspect there might be a threat there, we need to go pen test to verify, right? Okay. Oh God. Let's see. So that is okay. All right. All right. All right. So this is great. Okay, so this is perfect. So our inputs, if you look at the input object, um, where's the input object? This is perfect. I knew this was going to be great. Ah, ah, these people do great work. All the people in these W3c working groups do fantastic work. Just because they might have been funded by the government doesn't mean they don't do great work and they're not great people. It just makes me want another security review if I don't trust, the source, right? You're basically outsourcing your security review effectively to who you trust. And I'm saying I trust that Daniel has reviewed this stuff to an extent where I that we can trust it. Um, and then I'm going to send it to Matt, and Matt will tell us what he thinks. And then at that point, that's the final sign off as far as I'm concerned. Because if Matt thinks it looks good, then it's probably good. I would bet my bottom dollar on it. So we need to have some code to show him first, though. So. Okay. All right. Okay. Remember, we're reading it. We're reading it. Core data model. All right. Join me as we read the whole spec. This is why Alice is going to go over these videos so that hopefully if we find anything, we can pull it out and highlight it and show her how to do that. And that way she can basically, we'll use this as a training data for how she should be reading the spec and conceptually evaluating it based on like the verbiage and the linkage of URLs and like how she should traverse that chain, right? So basically these videos are the training data set right, to that, to these sort of more potentially more nuanced and English language based tasks that involve, you know, language, and mapping the language to the underlying code and spec. Um, and that's part of why we're doing these, and I'm explaining everything, as well as so everybody can understand, but also so obviously what we're building can understand. Um, let's see, use case requirements. There's a number of topics. These need marking verticals, use cases, and requirements. Okay, I really want some code. Um, we really need to read this. As the sections marked normative, all authority and guidelines, diagrams, examples, and notes in this section are normative. Okay, so these special keywords, these are very important. We need to remember these. So basically, may, must not, may, must, must not, recommend, and should in this document are to be interpreted as they are described in BC 14, RFC 2119, and RFC 8174. So once again, there we're seeing RFC, which is that broader scope, which these W3c specs are referencing. Now you're going to see the newer RFCs referencing the older W are the older W3c specs. Most likely, I'm sure that's in there somewhere. Some of them I'm just guessing, but because it becomes historical, right? And we're always building these layers of abstraction. I think we did the meeting minutes from um, the meeting minutes from 2 weeks ago, 3 weeks ago. Uh, we talk about building these levels of abstraction, um, and that 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 maps exactly. That's the software equivalent of what we're talking about here with these specs. Okay, so they appear in all capitals as shown here. The conforming document is any concrete expression of the data model that complies with the normative statements in this specification. So this is like a valid system context, I believe. Yeah, this is a valid system context. A conforming document is any concrete, if you're mapping it to the language that's in the existing Alice discussion, um, is the concrete expression of the data model that complies with the normative statements in the specification, specifically all relevant normative statements in section 4 basic concepts, 5 advanced concepts, and 6 syntaxes of this document must be enforced. The serialization format for the conforming document must be deterministic, bidirectional, and lossless as described in section 6 syntaxes. The conforming document may be transmitted or stored in any such serialization format. So that deterministic, bidirectional, lossless is the like what is in there as being DNA. Um, and the conforming document may be transmitted or stored in such serialization format. So this is what we said by basically may be transmitted or stored. So this is what we said by when we were talking earlier about just streams of bytes that you should be able to grab to understand. So this is this is aligning very well right now. Specifically, all relevant normative statements in sections 4 basic concepts, section 5 advanced concepts, and section 6 syntaxes of this document must be enforced. Okay, a conforming processor is any algorithm realized as software and/or hardware that generates and consumes a conforming document. Okay, a conforming processor. Okay, so maybe they've already done what we're talking about here. I think we might be doing an implementation of this then. Conforming processors must produce errors when non-conforming documents are consumed. Okay, so this is a shim. No, the conforming processor is the shim. Because that's what this shim does, is any algorithm realized as software and or hardware that generates or consumes a conforming document. That's the shim. This specification makes no normative statements with the regards to, okay, so this is, and so let's take some notes. Um, okay, so suspicious of government. Suspicious of government. Uh, okay, no. Let's rephrase that. So let's say threat model, nation state, threat model, attacker, nation state, U.S. government. Um, uh, and we'll say mitigation, or let's see, threat, um, key funding for the spec, or let's see, funding for the spec, um, cause for suspicion. Just taking a few notes here as we go. Um, our cause for suspicion was, did we already throw it away? Let's see. Okay. So we're just gonna flag this for like a little extra review when we go through if we do build on this. Oh, Seaboard, okay. Nate will be happy. Law enforcement. Law enforcement. That would be good though. The law enforcement should have attestation. That would be fantastic. That would be great. So see, there's a positive for this. Maybe they're doing it for a good reason. But we're suspicious, and they didn't say the word freedom. And this is America, and this is the world, and there should be freedom. Missing the word freedom. That's how they get you. Okay, so cause for suspicion. Threat, funding for the spec, cause for suspicion, mitigation. Mitigation 1. Ask Daniel. Can I just tag him? I can't just tag him. Twitter, or wait. I would just get it done right now. I just saw this video recently and said, don't put it down, put it away. Just do it right now. All right. CSU Wildcat. Let's go to the link so that if he comes here, he can say, okay, so all right, hey Daniel. Threat model, attacker, nation state, U.S. government, threat, funding for the spec, cause for suspicion. This causes for suspicion. Using the word freedom. Seems small, but in a world where potentially the government runs a piece of software that interprets the language of specs, I would argue the word freedom being missing from the spec is going to be a problem if the machine goes and reads that and says, well, I don't know, it doesn't have to be freedom preserving. It only has to be privacy respecting because the robot will go read it because we're going to make it do that. So it better only read things. That's also why we have our origins, input origins, and we have the ability to do thorough input validation so we can filter these things out from there was some recent work done where people said that you could by slipping some specific training data into a training data set, you could um, you could you could basically get it so that when it did inference, every once in a while, it would just give this really wacky answer, right? And that really wacky answer could be used to um, um, wait, is this working? Okay, it is working. Um, yay, Noah, red flag. That's hilarious. Yeah. Yay, Noah's sick. Yay. Okay. Um, okay. So, and where were we at? So basically, we're saying we're gonna make the robot interpret the spec. So, but this is the thing: is like if 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 Alice is really going to go build code, so what we're doing here is we're documenting, the process by which we go and sort of figure out, where's the edge of the field, right? Where's the latest specs that seems like they're going somewhere, right? And we've identified the Web3, the edge space, and the AI ML space are spaces where we're going to need to go, and we're going to need to understand what is the latest and greatest in that area because we're attempting we're attempting to look at the landscape of what open source projects out there exist, and we're attempting to say, where's the gap in that landscape, right? um, and uh, and we're attempting to fill that gap, right? Because we don't want to be working on something that is not helpful, right? So if there's something that exists, like if these DIDs conform perfectly and these verifiable credentials conform perfectly, we're not going to invent anything new. We don't want to invent anything new, right? I mean, we want to tie together as many things that exist as possible to integrate anything easily, right? Like that's sort of what we're going for here, right? When we want to integrate anything very easily, right? And then what we're going to do with that is that we're going to give that to, we're going to integrate the AI, and then the AI is going to be able to integrate whatever it wants easily, right? Um, so and so essentially what you end up with is this like shared communication, right? And this shared communication through this language of intent, um, and 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 we can basically because we have this granular level of uh, of understanding, right? Because we have complete visibility into the data that's going into this web of devices that accept the provenance as the understanding that something is following a strategic plan to the best of its abilities, as it is able to, based on the propagation of those plans through the network of the devices that it's communicating with, right? That's like sort of it's the best you can do, basically. Like you're doing your best, you're doing the best you can, right? Like like it's just, it's the acceptance that it's not going to be perfect, but as long as, as it's the acknowledgement that I'm going to do what I'm going to tell you what I'm doing, and I'm going to tell you that I'm going to do it to the best of my abilities, right, as a device, right? And you're able to then see that and say, okay, so um, looks like you are. I can see your attestation information, right? And then what data you got, right? And but that's like so in this edge case, right? So and if we to detect, so that means that we can detect one of these devices because the devices attest to each other in order to communicate, and you can say, hey, other device, I don't think I want to give you that information, right? If I detect that you're operating um, some software on there that doesn't assure me that you're going to follow your privacy policy, right? Or you're going to follow your freedom policy in this case, right? And so if you say that if you're going to so basically you get to define your own privacy policy, right? And you get to say, I don't give my data to devices that don't adhere to my privacy policy, my definition of a privacy policy, right? And well, what is your definition of a privacy policy? That's your own creation of these data flows, which we're going to have, this intuitive interface to create via basically, I mean, you're going to be able to drag and drop, or you're going to be able to literally just talk. The goal is to be able to talk and just describe what you want to happen, right? And or you can then come together as groups of people and say, hey, and these are the strategic plans. This is like, you can say, um, um, you can say basically, hey, the four of us got together and we thought, what is our privacy plan? What do we think should be done with our data? And that's this ad hoc formed organization. And so then you all can sort of communicate, your devices communicate through this distributed network, right, using this shared protocol so that they can talk to each other and exchange what the pieces of that plan are. And this is if you're looking at the layers of the strategic plans, like these conceptual levels, and where you and your friend basically are submitting each your strategic plans, and then that feeds into the overall strategic plan, which is the your ad hoc formed organization strategic plan, and that is your privacy plan, your what do I want to give my data to, right? And so basically when your device is making an API call through another device, it can say, hey, hold up, right? um, First of all, it does this handshake and it says, well, what kind of device are you? And if that device reports back, it has to basically, for my device to talk to it at all, it better tell me, you know, it better tell me something that says, "Hey, I'm a device that talks uh, the this I'm a device that talks in such a way that you can prove that I can prove to you that if you're talking to me, I'm not going to go do a bunch of sneaky stuff with your data, right? Because it has this attestation and this provenance chain of like, hey, if basically we can have this full transparency and visibility into these systems and say, okay, like we know that you're not doing anything that you didn't tell us about up front because we have the attestation information that maps to the actual code that you executed. So we know that you didn't execute any funny business, right? Um, and so the nice thing about this, and the reason why we want to put all of this on top of this, this uniform application layer protocol in terms of these DIDs, is then we can work together with our friends also via these shared protocols to say, and when I say our friends, we could be a little agent that's going and running some machine learning jobs, right? Um, we we can share the information that we have on the um, people collecting the data, and we can say, um, and we can say, hey, does it look like their activities, if we look at maybe like news stories or something, does it turn out that like, yes, they have this attestation by maybe a third party, like maybe something says it's organic, right? And you're like, okay, this is great, it's organic, I'm going to buy this thing, right? I want to be healthy, right? And so I'm going to eat organic food. And then you turns out that, well, actually, this is just some kind of shill organic certification thing. This one company that happens to be like the because they all say certified by, right? And then there's some, top level governing body there, right? And you happen to get the one that happened to be, they were somehow just skimming by and nobody had checked on them for a while and they weren't actually doing anything, right? And so it turns out this thing is full of pesticides, right? And so, this in this event, this is why, it's this dynamic protocol. And it basically is this queryable on demand thing, right? Where and customizable data sources where you can supplement whatever data you need, right? And that's our definitions and our and those input parents, which was basically we're going to turn the definitions into the input parent objects, and we're going to be able to track the lineage of any piece of data. And then we're going to be able to also, create new pieces of data that basically say, because basically what you can what you can do is you can just do the reverse if you needed to map something. If you needed to have like this like you can basically say, hey, if I um, want to uh, if I want to say uh, let's see. Okay, so basically what we can do is we can say, hey, if you read any specification, right, and we'll know whenever we parse a specification, we'll create an input object that says, hey, there was a spec, right, and that's the definition. There's an input object created of type spec, right, and we can say anytime you're looking at a specification, because a specification defines the way you're going to communicate with other devices, so only use specs that say that they are freedom and privacy respecting, right? And don't use any code that is not um, uh, implementing a protocol based on a spec that hasn't been shown to be freedom and privacy preserving. And then when you see in the spec for like the organic thing, who confirmed that this is freedom and privacy preserving? Well, mitigation one, ask Daniel. Mitigation two, ask Matt. So these are going to be our organic association people. They're going to be the ones who can tell us, you know, these are the experts that we've identified that we can trust, that we can say, hey, does this thing conform to what it says it does? This is in absence of an attestation where it proves that it's freedom and privacy preserving, then we need to have this, third party vetting system. And I think somebody was talking about this recently. Um, yeah, I think it was, yeah, Marcella Morella, I think is her name. And she is working on some secure compute stuff. And she was saying something about, you know, in toto, and how in toto, she's doing some cool work where I think she's gonna upstream to um, uh, both in Toto and Salsa, and she was saying something about this concept of these third-party verifiers, right? And this is also something that we've been having the discussion about in like the CVE space, right? Where it's like, well, what more information needs to be added to these CVEs, right? And it's the same thing that you have when you get into the SBOM and these package repositories with the namespaces. What you end up with is you really just end up with what do I need? I need this constant freaking link thing to this new system, new namespace, whatever, right? Okay, so what we're saying here is just use the DID. Everything's just a link to a link to a link. Just make another link. It's just like the input networks. Um, all right, okay, way too much. Way too much information. But that's all of the information, just so we have it all. Because the point of this is to have all of the information, and to create giant representations of it in ways that make sense, instead of just sort of saying it all over. Can I tell you a subject? Okay. Okay. So, hey Daniel. I don't want to ask him until we know more. I think we need to read the rest of this. So we'll say draft. Hey Daniel, funded by the government. That's right. Okay. Threat. And how far are we into the video? an hour and 11 minutes. Okay, probably. I mean, God knows how long that went on for. Maybe we'll put an hour. Okay, so let's grab that. We already got the link. Okay, so okay. Um, Yeah, and then basically, obviously, so we're gonna map the specs to the programs, and then basically, Alice, don't write any code that's good because what Alice is gonna end up doing, everything is an integration problem, right? At this point, I mean, so basically, what we're working off of is everything is an integration problem, and then beyond that, we start to get to, well, how do you create new things, and how do you create new things needs to be somehow more based on this, like, well, idea, well, what are you really trying to do here? Because, or else we risk what we want to do is we want to solve specific problems, right? And address problem statements. We don't want to just sometimes we just write a lot of code because writing code is fun. Um, but the less code we write, the better. And just because then we can get more done, right? Because we're not writing all the same code in different ways, different places. We're all just writing specific little pieces of code that do specific things, and we're using our domain specific expertise, in the most efficient way possible. And then, eventually maybe we see if Alice, via training models and stuff can get good at those domain specific expertise areas, but for now we're just really assisting people. So, okay, yeah, update. That's draft here. Okay. Okay, and this is already linked in the stream description. Great. Um, I want my other soda. What is a verifiable credential? Okay. Introduction. Wow. Okay, yes, that's right. So we have some code. Maybe we're just going to go look at some code. Verifiable credentials, data model implementation report. Oh, hey, this is what we were looking for earlier. Open attestation. Document endorsement and verification framework. Okay, so this is good. So this is great. This is great. So we're probably going to want this because we're about to grab random code off the blockchain and execute it. So we should definitely know where it's coming from and trust that. So, I mean, obviously within reason here, we're not grabbing random code. We're grabbing the prototypes, basically the function prototypes and how they're knit together. Nevertheless, it would be really good. What is this? Oh, this is great. This is definitely not what I thought it was, but this is great. What's this? Little badge. Uh, internship. Oh, internships. Mask. What is this? All right, go Steven. What people say about Steven. Oh, well, good for him. Well, this is great. This is awesome because we have another part of this, open certs. This is great. Drag and drop your open cert file. Open certs, open certs. This is great. We're gonna need this. Um, so why are we gonna need this? We're going to need this because uh, we would like to create a sort of review system. Um, yeah, we want to create a review system, and this is going to be a part of the way that we hold accountability in this network of automated edge execution, uh, where AI is making the decisions as best as it can. Is we are going to need some good um, data telling us um, uh, review system did jobs complete. So when we get to the part where we're going to start throwing these jobs at KCP, we're going to want to understand, we're going to run KCP in this multi-cluster. So I don't quite know what their threat model is, because but I know I have a strong feeling malicious clusters is not one of them. Um, so what we're going to do there is you could basically, it seems like you could sort of knit a bunch of clusters together as if it was one cluster. Um, I think the question is, and that maps to the concept of, and then we're going to implement everything as like job CRDs basically. Um, and then that, um, but the concept of the cluster maps to the operation implementation network, which in our architecture is there a trust boundary there? Is there a trust boundary on the implementation network? Well, there is no trust boundary because there's only one implementation, and the one implementation right now, um, the one implementation as it exists right now doesn't um, doesn't there is no trust boundary. The one off, yeah, uh, yeah, because there's only one. So, but if we started to get into something that's more like the sources API, where we have, one uh, operate like the sources API is a whenever you pass data sources, DFFML will take them and display them as if they're one thing. And when it does that, um, they basically go into this thing that's a collections user list, which is a subclass of the regular list, effectively. And so basically, it acts as like this transparent proxy for a list of treating a list of source objects as if it were one source, and so that it does the transparent iteration over records and updating of update and updating a record with update and pulling a record with record. Um, and we've had some issues with that. Will be solved with some of this stuff. We're still going to have to, that one's going to take some more heavy lifting. That was the only one that's designed like that. But the point is this open search stuff. So review system did jobs complete. So we need to understand, okay, so let's make a note about the trust boundary. Um, Trust boundaries need to double check trust boundary situation with um, KCP/opimpn, which is the Operation Implementation Network. Need to double check trust boundary situation with KCP/opimpn to see if hostile cluster could be made to be within threat model scope. Yeah, so if not, it's no big deal. I think we'll basically just interact. Yeah, we'll probably, Yeah, I need to look at KCP. Someone needs to look at KCP. I highly doubt that. I highly doubt it is out of the box. That would be really nice though. That's okay. We can always just, we have other ways of doing things. We can always make proxies. Um, so, like to filter over the API server because we're basically going to use Kubernetes as the orchestration for we're going to use Kubernetes for everything. So, or well, KCP for everything. So the API server is what we're going to use. So this can be used for the review system, which is how you get your, that's the same thing as your verification, right? So basically Daniel's going to issue a review, right? And that review is a certificate. Um, Effectively, that's what we're going to do. And then allows you to build your web of trust sort of thing, but where the edge, like the pieces of data are all these blobs instead of having to actually add signatures to things, unless I'm mistaken on how this all works, but we're just going to implement it and then find out. So, um, well, okay, we're going to do a lot of research, obviously. Okay. Issuance date, expiration date, expiration. And what is this? Verifiable credential. And what was it? Open attestation. So this doesn't look like this. So basically, where that open attestation thing, we need to go look at the rest of these. vc.js. That looks nice and lightweight. That name suggests I am a nice little JavaScript library. Let's see. And so it is. So it is. The name does not lie. Um, Short, sweet, to the point, well written. Um, so let's see. This is library for the verifiable credentials data model 1.0. When was the last activity? 21. Why is this all a year old? That's really concerning to me. Why has there been no movement for the last year? What are people working on? Is it just done and now they're going to do bigger implementations on top of this? Or are we missing something? Okay, so what can we do this? So we can use this for maybe generating threat model reports, right? We can run a bunch of security tools on a tested system and run security tools on a tested systems, uh, introspect throughout scanning to confirm that all files were scanned via strategic plan, analysis of data flow, slash system context. All files were scanned via strategic plan analysis. Okay. All right. So we didn't find what we needed in the verifiable credential API, but uh, registry. Okay. Hmm. So the thing is that when we do these when we do these certificates, so what is this? What is this? So what I saw was verifiable data registry, a role a system might perform by mediating the creation of verification of identifiers, keys, or other relevant verifiable for revocation registry. Some configurations might require correlatable identifiers for subjects. Some registries, such as the ones for UUIDs and public keys, might just act as namespaces for identifiers. I'm wondering if we can leverage the verifiable data registry. A set of one or more claims made by an issuer. A verifiable credential is a tamper-evident credential that has authorship that can be cryptographically verified. Verifiable credentials can be used to build verifiable presentations, which can be cryptographically verified. The claims in a credential can be about different subjects. Okay, so I believe an assertion made about a subject. I think we might be able to encode our system context within the claims. These are self-referencing. A claim is a statement about a subject. A subject is a thing which claims can be made. I think, okay, that's a key value relationship. Claims are expressed using subject property value relationships. Okay, so this is a key value relationship. So basically we have a key value mapping. So what can we do with a key value mapping? Well, basically everything. We can do everything we need to encode a data flow, that's for sure. Um, The individual claims can be merged together to express a graph of information about a subject. The example shown from figure 4, this is perfect. This is perfect. So this is, this is exactly what we needed. All right, let's hope. We're gonna hope that Daniel says the government is not out to get us on this one. And then we're gonna ask Matt and we're gonna say, Matt, does the crypto look like the government is not out to get us on this one? And then we will sleep soundly. Um, I mean, I think it looks good. It looks good to me, but um, I mean, the least we can do is have three people look at it. If we're going to build a bunch of stuff around it, that would be incredibly irresponsible to not have anybody look at it. So we have given it thorough suspicion, um, and now we're going to kick it down a line of suspicion. So it looks good to me, other than the fact that I don't know cryptography that well, and I'm not as plugged into this DID space, which is why I'm pinging Matt for the crypto, and I'm pinging Daniel for the DID, and the fact that I know that he's also, if I didn't know that he was uh, also, want somebody who would want freedom and privacy preserving, I would ping a third person. Not that I know Matt also wants that, but I would ping a third person in the DID space who I knew because that's important. Um, that would be, I would say that would be a successful mitigation of risk in this particular for this particular concern. Um, so looks like we can use claims. All right, use claims. DAGs. Okay. I think this is basically just, that's a trivial case, I think, of what we're writing down here. Here we are. So we're about to choose to have the verifiable credentials data model as a dependency. Currently, our train of thought, if we're mapping this to the language that we're using in the discussions thread, our train of thought is what we talked about in the last video. We've got sort of these, well, that's more multiple trains of thought, right? And then they're coinciding, or that's probably not the right word, but basically they're going to meet up, and I should go inside. I'm going to go inside. They're going to meet up, and then then at the end we're going to throw the ML on there. Um, Okay, going with it for now because it looks like we can encode DAG into claims. Should do everything we need. Be enough to get basic data flow or basic first stage system context within on-chain. All right, this has been wonderfully, wonderfully successful. We found out DIDs are indeed what we want. And we found out that not only are DIDs what we want, but we want these verifiable credentials. And we're then now about to go, when we pick up next, we're going to go and run the code from this verifiable credential data model working group after we double check um, the report card for the implementations, just to make sure that we know um, 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 what, that we'll go pick one that's suitable for us, right? Actually, so this is the test suite implementation. So we're gonna reference this reference to see if any we can use to better understand spec. Actually, I don't know. Enhancing privacy is a key design. All right. So this looks good. All we really care about right now is encoding into claims. I'm basically going to say that we can punt this to later to understand any of the rest of this. All we really need to do is get this into a format that we know is conformant, and then we're going to work from there, and then we're going to uh, rope people in that know this section of it and can give us some more guidance, or we'll figure this out next after we can encode the claims. Um, no, we shouldn't do that. We should probably make sure that we can use this stuff. We should make sure that we can use this stuff before we put something inside of the data model that we're not sure if we can use yet. Okay, so that's what we're going to do next. All right.